In this video, I am going to discuss remaining questions of chapter 1 exercise 1.4. So in the exercise 1.4 we are having 5 questions. Out of these 5 questions we completed question 1 and question 2. Now 3 questions are remaining, question 3, question 4 and question 5. So in this class I am going to discuss about these questions. Now first I am taking question number 5. And what about this question? Rationalize the denominators of. Now first I am going to explain how to rationalize denominators and why we are doing rationalization. So rationalization of denominator is, what is the meaning? Why we are doing? Because if denominators are having radical sign, radical numbers, if radical sign is in the denominator, it means what? Root numbers, square root numbers in a denominator, then we want rationalization. What I am saying, if denominator is having, I am just taking one example there, 1 upon root 2. Now this is rational or irrational? I already discussed if one rational, one non-zero rational and irrational division is what? Irrational. Discussed the operation of the real on real numbers. We studied one non-zero rational and irrational division and product is what? Irrational. So once we solve this one, how we will solve? 1 upon, and the value of root 2 is 1.414 and something. This is the irrational number, infinite. After point we are having infinite numbers. So this is not easy way to divide. So we want to remove this square root term, this radical term from the denominator to numerator. We want to remove this root. So in the rationalization हम क्या करते हैं, जो हमारे डिनोमिनेटर्स के अंदर जो ये रूट वाली टर्म है, if we are having square root term, radical term in the denominator, we want to remove that term from denominator and we want to convert denominator in a whole number. Then what we will do? We will do rationalize. इस रूट वाली टर्म को डिनोमिनेटर से हटाने के लिए हम रैशनलाइज करते हैं. वाई? बिकॉज दिस डिवीजन इज हार्ड, वी कैन नॉट डू इजीली. बट वंस वी रिमूव दिस स्क्वायर रूट टर्म फ्रॉम डिनोमिनेटर, then we can do easily. So how we will remove this square root term from the denominator? We will do rationalization of denominator. So once we do the rationalization of this number, we will multiply this number, multiplying and dividing of this one. How? We will multiply and dividing of this number 1 by root 2 of its denominator. So in the denominator we are having root 2. So root 2 will be multiplied and divided of this number, root 2 upon 2. हमें इस रूट 2 को हटाने के लिए, इस रूट रेडिकल साइन को रिमूव करने के लिए हम इस नंबर को रूट 2 से मल्टीप्लाई एंड डिवाइड करेंगे. So we are doing root 2 upon root 2. Once we multiply this number root 2 upon root 2, this is what? Once we remove both, we can cancel, we are getting the original number. If any number is multiplied and divided by the same number, result will be unordered. अगर एक ही सेम नंबर से मल्टीप्लाई और डिवाइड वी कैन डू, देन वी आर गेटिंग अनऑर्डर्ड नंबर. हमारे इस ओरिजिनल नंबर में कोई चेंज नहीं हुआ. 1/√2 if we multiply and dividing, we are doing √2 upon √2. This is what? 1. After solving we are getting 1. So original number is unordered, so we can do this one. But we want to remove this radical sign, so we are doing this one. So now we will multiply 1 into this one. 1 into this one is what? √2. And in the denominator we are having √2 into √2. If like this, then what we are getting? √2 upon 2. Now 1.414 so on divided of 2. This is the easy process of dividing. Now in the denominator we are having whole number 2. 2 is the natural number, so this is easily to divide this one, but this is the not possible. So for removing this radical sign, removal of this radical sign, radical means what? This root, square root, this is the radical sign. So if we are having denominator radical and we want to solve, so first we remove this radical from the denominator, then we will do. So how we will remove? We will multiply that number and divide by this one. If we are having single number like this, √2, √3, √5, and like this number, only single root number we are having, then we will multiply and divide by directly. But if we are having a plus b form, root of a plus root of b, like of this, or simply we can say, if we are having numbers like this, if we are having number a plus b and both are in the root, then what we will do? We will multiply and divide by its conjugate, and its conjugate is what? Its conjugate is √a minus √b. Its conjugate will be this one. This is one example. It means what? There may be one root or two root. If we are having a plus b, then its conjugate will be what? A minus b. Clear? So we will multiply and divide by denominator's conjugate. So what I am explaining there, I am solving question number, I want to solve question number 5.1. And what about the question number 5? Rationalize the denominator. And first we should know why we do the rationalization of denominator, because we want to remove this square root term from the denominator. And why we want to remove? Because we cannot divide easily. This fraction is not easily we can convert decimal form. So we want to remove this root. So removing this, we are having some process, and that process is called rationalization. So like this number we are having, normally single number we are having, we will multiply directly and dividing by same number. We are multiplying and dividing by same number. But we are having addition and subtraction in the denominator, then we will take what? Its conjugate. Its conjugate we will take and we will do. We will discuss later in the next question. Now I am going to rationalize. So what will be 1/√2? One example is this one. If we are having question 1/√2, rationalization of its denominator will be what? We will multiply and divide by √2. Then we are getting this one. So this will be our solution. What? This is our solution. Now I am taking question number 5, first one. Now I am taking question number 5, first one. And what is the question? 1/√7. This is similar to example. How we will rationalize denominator? 1/√2, √7 will be multiplied by this denominator part, √7, and divided by same. So what we are doing there? We want to rationalize denominator, so we will multiply and divide of this denominator. Clear? So what we are doing, 1 by root 7 into, we are multiplying by root 7 and dividing by root 7. So this is the process for rationalization. 1 into root 7, root 7. Now in the denominator what we are having, root 7 into root 7. So two roots, two same numbers root we are having, it means root will be cancelled, square root will be cancelled, and what we are getting, only 7. Yes or no? What is the, how we are getting this one? What is the meaning of this one? Root 7 divided of root 7 square. So how we can write this one? Root 7 divided of, root means, what is the meaning of the root? Root means power is 1 by 2 and whole power 2. Then what we are do? Root 7 divided of, we will apply what? Laws of the exponent. A power m whole power n, then this will be a power mn. A is the 7 power 1 by 2 into 2. So what we can write? 2 to 2 cancel. So we are getting root 7 divided of root 7 divided of 7, and this one like this. So its answer is what? After solving, we are getting root 7 by 7. Or directly we can say, if we are having denominators, two numbers, two same numbers root are multiplied, then we will remove the root and we will write directly number. And how it is coming? This is the exact process. So this is the solution of the question first of fifth one. Now what we are doing? We want to remove this root, square root. So we want to do rationalization of the denominator, or for the rationalization of the denominator, only single term we are having, then this single term denominator will be multiplied and divided. Multiplied and divided, then we are getting this one. Now next question I am taking. Question number second one. And what about this question? 1 upon root 7 minus root 6. Now in the denominators we are having radical signs, root 7 minus root 6. So we cannot easily to subtract and divide. So we want to remove these square root. So we will do the rationalization of denominator, and rationalization of denominator, if denominator parts having a minus b, then we will do what? We will take its conjugate. So conjugate is meaning is what? If denominator is having negative, then we will multiply and divide by its positive, and vice versa. If denominator is having negative sign, two numbers are in the denominator, and we want to a and b are two numbers are in the denominator, and we want to rationalize the denominator, then we will use its conjugate. Or what is the meaning of the conjugate? If negative numbers are there, minus sign in between two numbers are there, then this minus will be converted to plus and plus will be converted to minus. So we will rationalize. How we will do? We will multiply and divide this number by its conjugate of its denominator, and its conjugate is what? Root 7 plus root 6 divided of root 7 plus root 6. And why we are doing this one? Why we are taking its conjugate? Because in a denominator we are having, now just I am multiplying first, we are multiplying 1 to this one, we are getting root 7 plus root 6 divided of this one is what? Root 7 minus root 6 into root 7 plus root 6. Now in the denominator we are having a minus b into a plus b. This is the algebraic identity. A minus b into a plus b will be what? A square minus b square. So by doing conjugate, what we are getting in the denominator, we are getting the form of algebraic identities a minus b into a plus b, and then its result is a square minus b square, and after we square we will remove the root. So I am applying this formula there. Root 7 plus root 6 divided of a minus b, a plus b. A is what? Root 7 square. Minus b is what? Root 6. Root 6 square. Now root is there. Root 7 square. Again, what we are getting? Root 7 plus root 6 divided of root 7 square is what? 7. And root 6 square is what? 6. Like of this. So in this way, by rationalizing, we are removing root. And in that time there is no root, no square root, no radical sign in the denominator. We are getting what? Whole numbers. So this is what? Root 7 plus root 6 divided of what we are getting? Root 7 plus root 6 divided of 1. So answer will be what? Root 7 plus root 6. So I hope you are getting why we are doing rationalization, because we want to remove square root or radical sign from the denominator. If we are having radical sign in the denominators, then fractions to decimal conversion is not easy. So we want to remove, or we want to, how we will remove this one? By using rationalization of the denominator. If single term is in denominator, in the root, we will multiply and divide by same number. If two numbers add or subtract like this, if two numbers having addition or subtraction, then we will take its conjugate. Minus, then plus, plus, then minus. Why we are taking this one? Why we are taking conjugate? Because in this way we are getting denominator algebraic identity, this one. And in this identity we are removing square term. Okay. Now third one question. Now I am taking third question. And what is this one? Question number third. Third one. 1 upon root 5 plus root 2. Now again a plus b form in the denominator, so we will use conjugate of this number. And what will be the conjugate of root 5 plus root 2? Will be multiply and divide. So its conjugate is root 5 minus root 2 divided of root 5 minus root 2. What we are doing? We want to rationalization of the denominator. For rationalization, we want its conjugate. There is a plus, so we will use negative numbers, and that negative numbers will be multiply and divide to this number. Then what we are getting? Root 5, when we multiply this to this one, root 5 minus root 2 divided of, this is the a plus b, a minus b. We will use a square root 5 square minus root 2 square. This is the a plus b, a minus b. And a plus b, we know already, a plus b into a minus b is what? A square minus b square. This is the algebraic identity. So we use it there. Now then what we are getting? Root 5 minus root 2. Now its square, root 5 square will be 5. Root will be removed. And how it is removing? Observe. Root 5 square. This can be written as, root means, square root means power 1 by 2 and whole power 2. So this is in the form of a power m whole power n. So this will be 5 power 1 by 2 into 2. Result will be 5 power 2 by 2. And this is finally we are getting 5. Similarly we will do this one. So 5 minus 2, what will be the result? Root 5 minus root 2 divided of 3. This is the answer or rationalization of the denominator of this question. So in this way, what we received, in this way we converted this denominator, in this denominator radical signs removed, and we are getting 3 as a real number. Yes or no? 3 is what? Rational number we are getting, or we can say integers in the denominator. So now after solving this one, we can easily to divide. So we are doing the rationalization. Now next one, question number 4 I am taking. Question number fourth one. Now how we will do the question number fourth one? What is the question? 1 upon root 7 minus 2. Again, in the denominator we are having radical number, so we want to this radical sign, square root sign. So for remove this removal of this, we want its rationalization. Root 7 minus 2, this is the a minus b, so we will multiply and divide this number by its conjugate minus, so we will use plus. So root 7 plus 2 divided of root 7 plus 2. By multiplying this way, we are having same number. It means this one and this one is cancelled. We are getting again original number. No effect of the original number. Now how we are getting? Multiply this one. Root 7 plus 2 divided of this one is again a minus b, a plus b. What will be this? Root 7 square minus 2 square. Root 7 square minus 2 square. Result will be what? Root 7 plus 2 divided of this is the 7 and this one is what? 4. Result will be root 7 plus 2 divided of 3 and this is the answer. So once we solve this one, add this one, easily we can add, then we can divide and we will get in the decimal answer. Yes. So in all 4 questions, what is the main task? Again I am revising. In the question number 5, rationalization, the denominator, first we should know why we are doing rationalization. In the denominator, once we are having root terms, square root terms, radical numbers, then we want to remove that radical numbers. And why we want to remove this one? Because we are not getting easily decimal form. Not easy process. So we rationalize, and how we will rationalize? If we are having only single term in the denominator, no addition subtraction terms are there, then we will directly take this number and multiply and divide by that one. Clear? But in the addition and subtraction forms are given, then we will take conjugate of the denominator. Conjugate means if negative numbers are in the denominator, then we will take positive, multiply and divide, and if positive are given, then we will take negative. This is the rationalization process. Now I am taking question number 4th one. And what is the question? Represent root of 9.3 on the number line. So I am taking this one, root of 9.3 on the number line. So root of 9.3 I am writing there. To represent these types of the number on the number line, first we require baseline. So whatever number is in the root, use as a base. Take one baseline, AB I am taking baseline, and it is 9.3 units, or we can say 9.3 centimeter I am taking as a base. Then the second step is what? Add 1 centimeter or 1 unit at B. Add 1 centimeter or 1 unit at B. Then we are getting A to B is this one, and B to C is what? After adding 1 unit. So first take 9.3 as a base, then add 1 unit to this one. Now we will do half. Now A to C we will take half, and that half point will be O. What? First take A to B 9.3 units, then add 1 unit, then we are getting what? 9 complete length is what? Complete length of this one is 9.3 plus 1, it means what? 10.3 units. And half of this, half of 10.3 will be used for AO, OA and OC will be same. Then we'll consider OA as a radius and draw a semicircle. OA को रेडियस मानते हुए, इस OA को रेडियस मानते हुए हमें एक सेमी सर्कल बनाना है. Simple process is there. First 9.3 take as a base, add 1 unit. Then AC will be 10.3 units. Then half of this one will be there, half of this one. This is what? 10.3 divided of 2 units. This one A to O, half of. And using this as a base, OA as a radius, and draw a what? सेमी-सर्कल. OA रेडियस का हमने एक सेमी सर्कल बनाया. And then what we will do the perpendicular line on AC. Draw a perpendicular line on AC at B. यहाँ पर हमने एक परपेंडिकुलर लाइन डाली. परपेंडिकुलर मीन्स 90 डिग्री. हमने एक 90 डिग्री लाइन डाली and we are getting a point D. Again I am revising. First take AB is 9.3 centimeter, add 1 centimeter, then we are getting complete line AC. Then take half of this one and take point O. AC half will be the O. Then OA is a radius and draw a semicircle. Then what we will do? We will draw a perpendicular line on AC at B. B के ऊपर हमने एक perpendicular line डाली. Now use, this is what? This is the line going onwards. This is the A to B is the 9.3, 1 unit. This is the number line. This is the base line is what? Number line. Now take this BD as a radius and put using compass. Use compass, put pin there, pencil there, and draw an arc of this radius. Then we are getting like of this. It means, and this put E point there. So BD and BE are same. And whatever point we are getting, this will be the root of 9.3 on the number line. This will be the what? Root of 9.3 on the number line. Observe, first हमें सबसे पहले एक बेस लाइन लेनी है AB. देन 1 यूनिट उस पे बेस लाइन लेना है जो ये दिया हुआ है 9.3 बेस लाइन लिया. देन एड 1 यूनिट, उसके अंदर हम 1 यूनिट ऐड किया, 1 सेंटीमीटर ऐड किया. देन इसका हाफ किया और O पॉइंट ले लिया. AC का जो हाफ आएगा वो O पॉइंट होगा. देन OA एज ए रेडियस एंड ड्रॉ सेमी सर्कल. एंड नेक्स्ट वन, दिस इज द AC and perpendicular on AC we want a line. So where we will apply this one? We will put this point B. We will where we use perpendicular line at B. At the B we will draw a perpendicular line of AC, this one. And now intersect point of on semicircle. Intersect point of this perpendicular line on the semicircle. We are having D point and use this as a radius of this arc and draw a arc on the where number line, and whatever intersect point on the number line will be root of 9.3. This is the easiest process for drawing root of 9.3 on the number line. I hope you are getting this one. Now next question number 3. And what in this question is the easy question. How we will do this one? Question number 3. First read carefully. Recall what? Recall, this is a logic based question. Recall pi is defined as the circumference of a circle to its diameter. That is pi equal to, what is this? Pi equal to defined as circumference to diameter. One formula, pi is the circumference to diameter. That is pi equal to C by D. This seems to contradict the fact that pi is irrational. Pi equal to C upon D. it is showing pi is contradicted. There is a contradiction. Why? Because pi is the irrational, but C upon D is showing ratio P upon Q form, and it is rational. But there is no contradiction. Why? We know well pi equal to what? 3.1415 and so on. Exact value of pi is 3.1415 and so on. Exact value. But we know well, sometimes we use pi is approximate equal to 22 by 7. This is P upon Q form. But 22 by 7 is rational number, not an irrational number. But we use pi equal to 22 by 7. But we are not saying 22 by 7 is the irrational. No, it is a rational. Pi is not equal to 22 by 7. It is pi is approximate equal to this one. After dividing this one, we are getting a repeating block. So what we can say? What is the value of this one? Once we divide, we are getting 3.142857, 142857 and so on, like this. 3.142857 is the repeating block. So what is the conclusion in this question? Saying pi equal to C upon D, this seems to a contradiction. No, there is no contradiction, because pi equal to, we are using 22 by 7, but 22 by 7 is the non-terminating repeating, and it is a irrational, but equal to this one, it is approximate equal to. So similarly, whatever C and D we are having, they may be approximate, so there is no contradiction. So this is the conclusion of this question. So we can easily to understand, because pi is having this one, but this is approximate. Similarly, pi can be C by D, but C and D will be the rational, but value will be the approximate, this one we can say. So exact value of pi is this one. So there is what we can say in this question, it seems to contradict. There is no contradiction. Why? Because pi equal to 22 by 7, it is the approximate, and it is rational, when pi is irrational. Similarly, there is also one chance C upon D is a rational, but the value will be the approximate of this one. So we can say there is no contradiction. So what we studied in this exercise, in the exercise 1.4, in the 1.4 chapter 1, we completed all the questions, question number 1 to question number 5. So in the last class we discussed question 1 and 2. In this class we studied question 3, question 4 and question 5. In the question 5 is linked to rationalization, and for the rationalization, why we do? Because we want to remove radical sign from the denominators, and so we multiply and divide by its conjugate. Clear? And in the question number 4, we want to represent root of 9.3. Like this number, if we want to represent on the number line, then what will be the process I given in this class. Now in the first question, it is a logic based question, so I explained there. You will revise again and again, and you will perfect in these questions. I hope you are getting the old concept and getting more and more concept linked to number system. So that's all about this class. Thank you so much.